Hello, this video is about the Nobel Prize in Chemistry for the year 1905, given to Alfred von Baeyer for his discovery of the inert gaseous elements in air and his determination of their place in the periodic system. Usually there is a Nobel Prize lecture, but Adolf von Baeyer was not able to do so for one reason or the other and never did. Also, he lived on for a few years more, but he never did. So I took an alternative, an article on Alfred von Baeyer. Okay, indigo is the color of the kings of color. Quote from Sandberg. Indigo has the fastness against washing and against light, oxidizes slower than most other dyes, and its history goes back to at least 2500 before Christ. The nature of indigo was long unclear, and it was believed, many believed it came from a mineral. Scientific investigations began early in the 19th century. Then its atomic mass was unknown, nor was its formula or structure. Much work was done by Adolf von Baeyer. He worked in a modest laboratory together with Grabe, Liebner, and Meyer. Researches into indigo started around 1865, and Canizaro's ideas about the scale of relative atomic masses was gaining acceptance. Bayer's structural elucidation was completed in 1883. In the meantime, structural organic chemistry had developed considerably. The successful synthesis of indigo remained a target. Some think Bayer was driven to free Germany from the rule of the natural indigo industry of England, which used natural indigo coming from India. A route from coal tar to India seemed to be plausible, also due to Perkins' discovery of movine in 1856 and the work on the synthesis of alozarin. There is no evidence of a nationalistic drive by Bayer, and his later involvement with German industry was an enthusiast. Bayer had earlier worked on murexide, a violet dye. This dye was popular for a while, but washing in too hot water destroyed it. In 1841, Bayer and Knop reduced isotin, the product of oxidation of indigo, to dioxindole and oxindole. He saw similarities with the reduction products of alloxan and believed that alloxan and isotin were also similar. See figure 2.1. We go to that later. In 1823, Crum determined the formula of indigo. CH, there's 8 common atoms, 4 hydrogen atoms, 1 nitrogen atom, and 1 oxygen, but later it was revived to C8H5NO, meaning 1 more hydrogen atom. But Somaraga proved in, this must be probably 1817, that it was actually, maybe 1917, we'll look into that, C16H10N, this double of what was found here. It was known since 1926 that indigo fused with sodium oxide would give aniline. In 1841, Fritsch discovered that less extreme, less basic, alkaline conditions would yield anthralytic acid. Bayer started an investigation based on the idea that indigo was monomeric. Indigo vapor was let over heating zinc, giving indole, the mother substance of indigo. Grabe and Lieberman showed the connection between alizarin and anthracene. Bayer did not engage in the controversy around the formula of indigo. In 1868, he reduced indigo to indigo white, or leuco-indigo, I hope I say it right, by adding a hydrogen atom. It was known then that hydrogen is a diatomic molecule, there's 2 atoms. Thus, to accommodate that the formula of indigo had to be doubled, see formula A, the molecule was believed to be symmetrical also. You see that it's indeed probably 1870 here, and talking about that time period. He was wrong as Bayer, proposing a parallel-slide connection between the 2 halves, but it was conventionally seen at that time. In 1869, Bayer investigated indole again, hoping it would boost his indigo research. He suggested that indole could be built as in scheme 1. Yeah, we're going to have to look at it. Here it is. if you want to follow the chemical exact details, you can better stop the video or go to the original article, which following this link, which will all be added in the description of the video. We go back. A year later, drawing on Bayer's work, he proposed today's structure of Indo. So we have to find that formula B. Where are you? Here it is. And you can see that not all the atoms are named. You see here a benzene ring and next to it. The approach changed there after that. Before, the dye stuff was degraded to known molecules. Now the emphasis, that's just analysis. Now the emphasis was on constructing molecules, the synthesizing. In 1870, indigo was made from difficult O-nitroacetophenone, zinc, dust, and soda lime. Baeyer followed with a more rational route using yellow phosphorus. See scheme 2. That's just another. Here it is. If you here it is. If you want to follow the details, stop the video or go to the original article. Yeah. Further insight made him produce indigo in a different way. Scheme 2, that he just did that. Indigo had to have its two phenyl groups connected by an inline chain of 4 cadmium atoms. See figure 2.2, we just saw that. For Bayer's representation of indigo's possible structure. His proposal was not approved by all chemists, but it was clear later that there were two symmetrical half rings connected by 4 inline carbon atoms. There are benzene rings and indole rings moieties. In 1878, Baumann isolated indoxyl as its sulfide. Baumann and Thielemann found that it could be oxidized to indigo. Baeyer went along and found 2 varieties, anal and pseudo-indoxyl. In 1880, scheme 2. We're going to look at it a little later, almost done. The latter could be made via condensation with carbonyl compounds into a compound with the characteristic blue spectrum. Again, see scheme 3. Baeyer had used such a condensation in 1881 to synthesize red indurubin, which was isolated by Schunk in 1879, just 2 years before that. Baeyer then used pseudo-indoxyl, condensed it with isotinton indurubin, the indogenide of isotin, scheme 4. It had 3 carbon atoms instead of 4, and condensation of the other carbonyl group gave it its 4-carbon bridge. And that is the summary of the article which led Baeyer to the synthesis of indigo. If you want to read the complete article, which is has more argumentation, of course, follow the link also in the description. Then we can look again at the figures. Here you have the synthesis of indole. Here you see another figure with compounds that are named in the text. Yeah. You have to study this carefully by yourself, of course, step by step, if you want all the details known to you. Here you have the scheme figure 2.2, and you see that the indigo is represented as symmetrical, as you can see. This is a way of representing it. It's symmetrical. Here, this is the X, and here the X is here, top down. Okay. Here more schemes with how you get to the different compounds used in the text, and the same is true for this one, of course. Okay, well, as of this is a general lecture, of course. If you want to know all the details, then you have to read the article, which is available via the link in the description. Here you see indigo blue, and this is what most used for, of course, still today. This was it. Next week, we're going to continue with the Nobel Prize in Chemistry for the year 1906. Thank you for watching. Maybe till another time.